Hi guys, so I'm Patricia Bermudez and I will be your host for today's video. And for today's video, we will be discussing a type of closed system, which is isochoric. So the problem states that a group of 50 persons attended a secret meeting in a room which is 12 meters by 10 meters long and a ceiling of 3 meters. The room is completely sealed off and insulated. Each person gives off 150 kilocalories per hour of heat and occupies a volume of 0.2 cubic meters. The room has an initial temperature of 101.3 kilopascals and a temperature of 16 degrees Celsius. Calculate the room temperature after 10 minutes in degrees Celsius. So what can we deduct from the problem? You can see that it is sealed off and insulated. What does this mean? No heat enters or leaves the room. So we know that the only heat that circulates within the room is the heat that is given off by each person. All right. And we also know that it's isochoric kasi the room won't change its volume. It won't adjust to the people inside. The room will still remain as it is, and the volume remains the same. So there is no change in volume, and thus there is no work. Because it's the change in volume that comprises work. So work is zero. And we know that Q plus W is equals to delta U. This one get cancelled out because it's zero. So what is the formula for delta U? It is N CV delta T. And it makes sense because the heat is measured at constant volume. And in this problem, the room remains the same. The volume of the room remains the same. So the volume is constant. So the heat then becomes NCV delta T. So in order for us to be able to use CV, we have to assume things. First is that the air that circulates within the room is ideal. Kasi hindi natin magagamit tong CV if it's not ideal. And we also have to assume that the air is mostly composed of nitrogen and oxygen. And these are diatomic gases. And the CV for diatomic is 5 over 2 R. Okay? So let's list down the given parameters. First is that the volume of the room is 12 meters by 10 meters by 3 meters. So we know that it is 360 cubic meters. That's the volume of the room. And the volume that each person occupies and the volume that is occupied by all 50 is equivalent to by 50. 0.2 cubic meters times 50. So that is 10 cubic meters. So the volume occupied by the air is 360 minus 10 cubic meters, and that is 350 cubic meters. All right. So we now have the volume occupied by the air. Now we have to find the Q, right? Because in this question, it is the Q that is equivalent to this. And our target here is to find this one. so that we can find the final temperature. So the Q is actually given by the amount of heat given off by each person. So the Q of the room is equals to the negative heat given off by each person, and the 50 people in total. All right, so the Q of the room is equals to negative, and since heat is given off by each person, it is also negative heat. So 150 kilocalories per person per hour. No? So with that, we have to multiply it with conversion factor so that only calories will remain in the unit later. So how many people are there? 50. 50 persons. And then in 1 hour, there is 60 minutes. And the time indicated here is 10. So we have to multiply it by 10. And you can see in the units that this one gets canceled off, and the hour as well as the minute. So what remains? Kilocalories. Okay, so let's calculate. So the two negative signs will cancel off each other. So 150 times 50 divided by 60 is 10. It is 1,250 kilocalories. That is the heat that circulates within the room. So we know that Q is equals to NCV delta T. So there is a missing value here, which is at the end. So we have to find that out first. So we know from this that the initial pressure is 101.3 kilopascals. And the initial temperature is 16. So this one is T1. And then this one is T1. And the volume is constant. This is the volume. This is the volume. So using ideal gas law, which is PV to nRT, to get N, we have PV times divided by RT. So N is equals to PV, which is 101.3 times 10 raised to 3 pascals. Kasi kilo siya. So in order to convert it into just pascals, you have to multiply it by 1,000. That's P. And then V is 350 cubic meters divided by R. So for this, we can use 8.314 joules per mole Kelvin. And we know that Pascal multiplied by meter cube, to know that Pascal meter cube is equals to joules. 1 Pascal meter cube is equals to 1 joules. So we have 8.314 joules per mole Kelvin. And then the temperature initially is 16, but you have to convert it into Kelvin. So 16 plus 273.15 Kelvin. You can see that the units will cancel off each other again here. So Pascal meter cube is joules. And then Kelvin gets, so what remains? Mole. This one is in the denominator, so it goes to the numerator now, and that will be the unit for moles, right? So let's calculate. 0.3 times 10 is 3 times 350 divided by 8.314 times 16 plus 273.15. The number of moles is 147.48. So it's 14,748.37844 moles. Yep, medyo malaki, but it makes sense kasi it is situated like in real life, diba? Maraming moles of air that is in the air. Okay, so let's make another slide. So now, the next step is to equate this, which we will calculate later, with this. So Q here is 1,250 kilocalories. So we know, we calculate NCV delta T first. So NCV delta T is equals to, what's the number of moles? 14748. So 14,748.37 0.37844 moles times CV, which is 5/2, and RR is 8.314 joules per mole Kelvin, times T, which is T2 minus 16 Kelvin. All right. So here, na-inject na natin yung T2, which is our final goal to find in this problem. And we know that this is Q, and Q is equals to 1,250 kilocalories. But we have to make the unit consistent here. Kasi ito naka-kilocalorie, but this one is in joules. Kasi maka-cancel off. Ito, moles. Kelvin gets cancelled off. So matitirang joules. But this one is in kilocalories. So you have to convert it into joules. So kilocalories is equals to 1,250 kilocalories. What do you have a conversion factor? 1 kilocalorie is 1,000 calories. And 1 calorie is equals to 4.184 joules. So this one, converting is 1,250 plus times 1,000 times 4.184. And yes, you have a big value again, which is 52, 5,230,000. 5,230,000 joules. So ito yung Q natin. And this is also our Q with an unknown. So we have to equate these two together to find the unknown. Yep. So Q is NCV delta T. So this is CV, this is Q. So 5,230,000 joules is equals to this whole equation here, which is 14748.37844 moles, 5/2, 8.314 joules per mole Kelvin times T2 minus 16 Kelvin. And now, in order to isolate this, we divide this by this. So T2 minus 16 is equals to 5,230,000 joules over this whole thing. Let's calculate this, okay? 14748.37844 times 5, 2 times 8.314. Itong value na to is equal to 306,545.0459 joules per Kelvin ang unit natin dyan. So, divide mo siya dito. 306,545.0459 joules per Kelvin. So, makakancel ang joules. And the Kelvin here in the denominator goes into the numerator. Why? Kasi nasa denominator siya ng denominator. So, ayan. So, T2 minus 16 is equals to 5,230 divided by 306, 545.0459, which is 17.0661, sorry, 1803 Kelvin. So T2, if we transpose this, it becomes plus. So T2 is 17.066 plus 16, which is 33.066 degrees Celsius. Yep. This is in degrees Celsius. This whole thing is actually in degrees Celsius, but when we calculate the change, it's equivalent to the change in temperature in Kelvin. But since 16 degrees in this question, you see, is in degrees Celsius, T2 ay naka-degree Celsius na rin. So, T2 is the final temperature of the room. I hope you learned a lot from today. Thank you for listening, and goodbye.